So now we're going to get tricky. All right, so we've already talked about grams to moles. And we said in order to do this, we can go back and forth as long as we have formula weight. But you know, there's something else that we've talked about too up to this point, and that's Avogadro's number. And we said Avogadro's number represents the number of molecules, or the number of atoms if it's just one thing off the table, or the number of ions if it's a charged atom, right? And we can go back and forth between these two things as long as we know a key step. We need a link, right? We need this common translation. How can we go from mole to molecule, or mole to atom, or mole to ion? Well, this is Avogadro's number. That's what we need to use there. And Avogadro's number will be the key step, because you got to remember, it said that 1 mole is Avogadro's number of anything, no matter what it is. So that means that 1 mole is equivalent to 6.022 times 10 to the 23rd of whatever we have. So that's why I told you to memorize that number, because we'll be using it. And now's the time where we will begin to use it. Now keep in mind, there's not a direct connection between gram and molecule, right? You can't go that detour. There's not a route that exists that you can take your car on that would get you to that point. You have to go to mole first. So here's the scenario. Sometimes they'll give you mole, and they'll say how many molecules. That's easy. That just requires Avogadro's number, and that's it. Very similar to what we've already done and setups that we've done so far. Or they can give you the number of molecules, and they can say how many moles is that. Again, very similar to what we've already done. It requires one step. The only thing we need is Avogadro's number in order to get there. The problem is if they give you grams, and they want molecules, atoms, or ions associated with that number, there's not a direct step here. That means we have to be comfortable of going from gram to mole, and then go from mole to molecule like we would prefer to do. But we have to get to mole in order to solve for these types of problems. If the problem asks for number of molecules, the number of atoms, or the number of ions, we have to get to mole no matter what. All right, so let's kind of do an example. Quit talking. Show me the proof. Look at the first one. Let's say that we have 2 moles of sodium atoms. We want to know how many numbers of atoms do we have. Individual little sodiums that are maybe right there in my weigh boat, or in my dish, or in my container. If I cut a 2-inch or 2 mole block of sodium, how many atoms are present? Okay, so this is how we do it. Surprisingly, we take 2 mole over 1. God, I guess you didn't see that coming, did you? And the next one, mole on top. So mole is going to go on the bottom. And we need to get to atoms. So the question is, can we go from mole to atom? Ding, ding, ding. Yeah, we can. Mole to atom, mole to atom, mole to atom. We need Avogadro's number. So Avogadro's number means 1 mole. There's my mole. I put a 1. Is equal to 6.022 times 10 to the 23rd. So 6.022 times 10 to the 23rd. And this is sodium. It tells me it's an atom. So it's the number of atoms that are here. I should know it was an atom because it was just sodium straight from the table. So it should be an atom. All right, so here's where the scientific calculator is going to come into some importance at least. Notice it says scientific on my computer. If you're using a TI calculator, it will do it for you as long as you enter it in the right way. So kind of copy me with it. So I've got 2 moles, 2.00, and I'm going to multiply now, parentheses, 6.022 times 10 to the 23rd. So we're going to multiply by 10 to the, and right here it says 10 to the x, right? So I'm going to hit that button, and then I'm going to do 23. No, sorry, just messed up. Hold on. 2.00 times parentheses 6.022 times, on this calculator, I'm going to have to hit 23 first and then do 10 to the. So 6.022 times 10 to the 23rd. I'm going to close the parentheses up, and then I'm going to hit enter. So here's my number. It's not in scientific notation, but your calculator will be much better than mine. It will probably go ahead and give you the number for the exponent there at the very end. I just can't show you my calculator screen. So here is 1.204. So over here to the side, 1.204 times 10 to the, we're going to have to count them, folks. Bear with me. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So 10 to the 24th. So that's how many atoms are present in that sample that I have weighed out. If you do this with your TI calculator, it will probably present you the number that way, which is perfectly okay. That's all that we need, right? Just key it in, 10 to the exponent button. Your exponent button on the scientific calculator looks like this. I call it the caret button. So you will type in 6.022 times 10 caret 23 and close that parentheses up, and it will understand what to do with that number, and it will probably present you an answer that looks like 1.204 E24. Well, that E represents times 10 to the something, right? So the E, think of exponent, 1.204 exponent 24. What they're leaving out here is the times 10 to the 24th. The times 10 is left out of the calculator. All right, so let's do another one. We're going to go to our second example, and it's going to be similar. 1 mole of N atoms. All right, so I take my given 1 mole over 1, mole on top, mole on the bottom, and I need to calculate the actual number that I have. Okay, so we've already said that 1 mole is 6.022 times 10 to the 23rd atoms. All right, well, this one's going to be easy. Anything times 1 is that number itself. So 6.022 times 10 to the 23rd atoms is what I have here. Okay, easy enough. That's all there is to it. Let's do another one. We're looking at 46 grams of sodium atoms. We want to know how many atoms we have, right? Well, here's the key. Gram can only be going to mole. Once I get to mole, I can then go to atoms. But I've got to get to mole first. So we've already discussed how to go from gram to mole. That's formula weight. Mole to atom is Avogadro's number. And that means this is going to be a two-stepper, people. Pick up those feet. So 46 grams over 1. And in the next step, gram on top, gram on bottom. Well, I can go from gram to mole, but that's about it. So I have to put mole here. Well, what number connects the two? It's formula weight. So I need the formula weight for sodium. Well, if I go back to the periodic chart, there's sodium at number 11. The formula weight's 22.99. That's it, right? It's just sodium. There's just one of them, no more than that. So the formula weight is 22.99 grams per mole. So there's gram, 22.99 for every 1 mole. But I can't stop there. I got to bring in a second stepper. Mole on top, mole on the bottom. And I need to go to atoms, right? Once I go from mole, I can get to atoms if I know Avogadro's number. Well, that one's easy. That one's never going to change. 1 mole of anything is going to give me 6.022 times 10 to the 23rd of those atoms. All right, so this is how I key in those steps. I'll take 46, and then I'm going to divide it by 22.99. And then I'm going to multiply it now because that number's on top. Parentheses 6.022 times 10 to the 23rd. So remember, on this calculator, I've got to do 23 first and then do the 10 to the x, right? And I can see that shows up like it should on your calculator that you're using at home. And then I'm going to close that parentheses up. So 6.022 times 10 to the 23rd. The calculator understands to do that first, and then multiply, and then divide as needed. So now I'm going to hit enter, and there's my number. So I'm going to get 1.204, it looks like. 1.204, we'll round it off. 1.204 times 10. So I'll bring the calculator up, and there's my decimal right here. So I'm going to count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. And that's how many atoms I have in 46 grams. Now, if you did it with your calculator, it probably would show up 1.204 e to the 24. And that's what that e means. All right, we're going to do another. This time it's 3 moles of K plus ions. No big deal. It's an ion. We treat it the same. So I take 3 moles, divide it by 1. Then I bring in my next step, mole on top, mole on the bottom. I can go from mole to atom in one step. That's not a big deal. But in this case, we're going to an ion just because we have that charge. And in 1 mole of anything, there's 6.022 times 10 to the 23rd of that substance. So I'll bring in my calculator, and I've got 3 times, parentheses, 6.022 times 10 to the 23rd. So 23 to the exponent. So that's how it should look in your calculator. 6.022 times 10 to the caret 23. We're going to multiply that by 3. And we get 1.806 times 10. And I need to count them. That's what I get for using this crappy calculator. So there's 3, 6, 9, 12, 15, 18, 21, 22, 23, and then finally 24. So 10 to the 24th. Or in your calculator, E24. And then finally we'll do one more. This is 68 grams of H2s molecules. All right, so 68 grams over 1, gram on top, gram on bottom, and I need to go to mole. That's the only thing that I can connect right now, and I need the formula weight in order to do that. So I need the formula weight of H2s. So I'll pull up the periodic table. H is 1.01, and there's 2 of them. So 1.01, here, let me clear that out. 1.01 times 2. And sulfur is going to be 32.07. So there's the formula weight for H2S, 34.09. So down here, I'm going to write formula weight is 34.09 gram per mole. So over here to the side, 34.09 gram per 1 mole. Now I can't stop there because we want molecules, right? So mole on top, mole on the bottom, and I need to get to molecules here. Well, once I'm in mole, I can go to atoms or molecules or ions or whatever I need as long as I know Avogadro's number. So in 1 mole of anything, there's 6.022 times 10 to the 23rd. So I'm going to bring in the calculator and we'll do this one last problem. 68 divided by 34.09. And then I'm going to multiply by parentheses 6.022 times 10 to the 23rd. Close those parentheses up and hit equal, and I get 1.201 times 10 to the 3, 6, 9, 12, 15, 18, 21, 22, 23, and 24. 1.201 times 10 to the 24. Don't get comfortable with that answer. It's not going to work out that way every single time. It just so happens with us. But put down the process, and I think that you'll be okay. So if you can do the problems in this video, I think you're ready for the next assignment. It's going to be nothing more than relating molecules and moles like this. And I think that you'll make 100 on that too. At least close to it, hopefully.